In this example, we're going to go ahead and solve a trigonometric equation for all solutions in the interval from 0 to pi. So the first thing we have to do is recognize that our equation 3 cosine 2 alpha equal to 3 cosine squared alpha minus 2. So notice that alpha is our angle, and our angle will be in basically 1 revolution. So the first thing we have to notice is this double angle. So we're unable to maybe use some algebra technique right away. We have to go ahead and rewrite it. So the first thing is all angles are consistent. So we just want to make sure that all the angles are alpha only. So we can easily do this by going to looking at our trig identities. And we'll notice here that we have a cosine of 2u is equal to some the 3 different identities in which we can use for in any way we want. So you notice all of them are written in singular angles, and we don't want the sign because then it's not the same trigonometric function, which makes it kind of funky. So we have to choose between the first one and second one, and of course the first one has sign in it, so it definitely by process of elimination I'm going to go ahead and use the 2 cosine squared u minus 1, and then I'll just rewrite u to be alpha. So writing that identity, we'll have cosine of 2 alpha is equal to 2 cosine squared alpha minus 1. So rewriting the equation, I get 3 cosine times 2 cosine squared alpha minus 1 equal to the right side 3 cosine squared alpha minus 2. Now just be careful and notice that I just replaced the double angle with the identity we found on the other page. So notice that you have to distribute the 3, don't forget the coefficient, and we get 6 cosine squared alpha minus 3 equal to 3 cosine squared alpha minus 2. And so applying some algebra here, we'll go ahead and isolate the cosine squared term and then put constants on the right. So on the left we get 3 cosine squared alpha equal to 1. And just doing a little more algebra, we get cosine squared alpha equal to 1/3. And if I went ahead and rewrote this as cosine alpha equal the square root plus or minus 1/3. So there are 2 solutions here that's happening. The first solution is that cosine of alpha is going to be the positive 1 over the square root of 3. The other solution is cosine alpha is equal to negative 1 over the square root of 3. So there's a couple of things happening. Let's go over here and make some more notes. So you'll notice that if all students take calculus, so just for this first solution here, okay, that we see that cosine here is positive. So where is cosine positive on the Cartesian coordinate plane, right? So cosine is positive here and also in the 4th quadrant here. If I go ahead and look at the other solution of cosine here being negative, cosine is only negative in the 2nd and 3rd quadrant. So here we're going to have 2 angles here because we're going from 0 to 2 pi, that we're going to go ahead and look for angles with the negative value in quadrant 2 and quadrant 3. And then over here, where cosine is positive, we're only going to look for angles in quadrant 1 and quadrant 4. And I say this because we're probably going to have to use a reference angle in each of the quadrants and then, subtract. So just also note that, remember, it goes 0, pi over 2, pi, and 3 pi over 2, and 2 pi. But just to give some clarity, because when we use the calculator, we tend to get decimals, remember that pi over 2 is approximately 1.57, pi is approximately 3.14, 3 pi over 2 is approximately 4.71, and then 2 pi is approximately 6.28. And that just gives us an idea of when we get to the calculator to compare which quadrant it's in, and then we know which solution it is. So I want to rewrite this using arc sine, right? So if I just scroll up a little, so inverse cosine of 1 over square root of 3 is equal to alpha, and inverse cosine of negative 1 square root 3 is equal to alpha. And again, remember that we're looking for particular quadrants in each one. Okay, so if I go ahead and put this in the calculator, and of course always make sure that your calculator is in radians as mine is, and that way we can go to functions inverse cosine of positive 1 divided by the square root of 3, and then close the parenthesis. And we can see the first one is 0.9555, which would be rounded as 0.96. So alpha here is 0.96. Now if we went over to the Cartesian coordinate plane, we can see that this angle is somewhere in the first quadrant, right? So here's alpha, right, 0.96. So we have the first quadrant. Now we need the fourth quadrant. So the fourth quadrant here, again, using symmetry, this is going to just be 2 pi minus the alpha, and that'll give us that angle. So going back to the calculator, I'll put 2 pi minus 0.96, and I get 5.32. So we can see, I'll put a little quadrant alpha sub 1 and maybe alpha sub 4, so we know which quadrant they're in. So now we found 2 angles in the first and fourth quadrant. Now let's go over to the second and third quadrant. Let's go ahead and take the inverse of cosine of negative 1 over square root 3. So I'm going to go ahead and go up here to the first one and just add a little negative here. And you can see that it gives me 2.186, and then I'm going to go ahead and round to 2 decimals, 2.19. And 2.19, if we go back up here, we could see that this is in the second quadrant. But that's this whole alpha, right? So this would be alpha sub 2. So to find alpha sub 3, using symmetry, right, we're going to have this reference angle here. So really what we're going to do is have to do a little work here. So we could take pi, find the first reference angle. So pi minus alpha would give us the question mark. And then really what we're doing is going to then take the question mark and add pi. But really what this is that it ends up being 2 pi minus alpha, and that's what we'll end up doing. So 2 pi minus alpha sub 2 is alpha sub 3. So alpha sub 3 would be equal to, going to our calculator, just deleting that and putting 2.19, I get 4.09. And just double checking with the Cartesian coordinate plane, it's surely between pi and 3 pi over 2. So the angles here are going to be, alpha will be 0.96, 2.19, and 4.09, and 5.32.